Hi folks. So in this video, I'm going to talk about Kubernetes liveness probes. So in the Kubernetes world, when a pod is scheduled to a node in the Kubernetes cluster, the kubelet that's running on that particular node will run its containers, and from there on, it will keep them running as long as the pod exists. So we know we have studied in the past that in Kubernetes world, the smallest unit is a pod. Within a pod, there can be containers. So those containers keep on running as long as the pod exists. For some reason, let's say the container's main process within the pod crashes, the Kubernetes' kubelet will make sure it will restart the container. For example, if your application has a bug that causes the main process to crash, no worries. If you're running in the Kubernetes world, in the Kubernetes cluster, Kubernetes will make sure that the pod will get restarted and so forth. But that's not the only type of problems that we normally encounter in applications. Applications don't always crash, but it can stop responding in different other ways without crashing. For example, in a Java app, let's say, a memory leak could cause an out of memory exception, whereas the process will still keep on running, but your application wouldn't respond to normal operations and so forth. So this is still a faulty case. How does in Kubernetes world we can detect these kind of problems? That's where these liveness probes actually come in. So the liveness probes are a mechanism by which we can determine whether a container within a pod is still alive or not. In fact, in Kubernetes, we have a couple of ways to determine that. So that we can have three different types of probes in Kubernetes. One is the HTTP GET probe. So meaning in your process or in your container, if you have an HTTP endpoint, and let's say if it's a GET resources being implemented, you can use that GET resource. You can call that GET resource to make sure whether that particular container is up and running or not. So if the container process returns a 2xx type of status code in the HTTP return message or 3xx status code, Kubernetes will determine it as a successful message and assume that the process is still up and running and it's alive. But if in case if it returns a 5xx type of an error, for example, 500 internal server error, that can be considered as a problem in that particular process, and you can instruct the Kubernetes to restart the container in case if it returns 5xx. So liveness probes are a way to do that. So if you just add a liveness probe to your Kubernetes YAML files in your definitions, Kubernetes will make sure that when it calls that particular HTTP resource, and if it gets a 500 or 5xx type of an error, it will restart the particular container or the pod. So there are other types of probes as well. For example, there is a probe for TCP socket, right? So which is essentially an IP address and port combination. You try to connect to that particular combination, and if the connection was successful, then all good. If it's not, Kubernetes can restart that particular container or the pod. So there is an exe probe as well, so which basically stands for you can instruct the pod to execute a particular command, an arbitrary command inside the container, and determine the success based on the return value. Usually a 0 return value of that particular command can mean a successful response, otherwise it can mean a faulty response. And if a faulty response happens, Kubernetes can restart. Let's see an example of how this Kubernetes liveness probe works. Right, so let me exit out of these and let's try to. Okay, so now I have few applications here, so I'm going to use this simple faulty.yaml. So basically it's going to create a pod here, and as you can see, the container is the busybox, the popular busybox from the registry of Kubernetes. I'm taking out of that. So basically here, the particular argument that I'm trying to the main thing that I'm trying to do here is like I'm creating a new file called temp healthy and then sleep for 30 seconds, and after that I'm removing it and then again sleeping for 10 minutes here. And in the liveness probe, this is the most important section for this particular video. And as you can see, I'm executing a command, and simply the command says cat, and the argument is this. So obviously if that file doesn't exist, it's not going to work, right? So the particular uh, value, the initial delay when this command goes on is 5 seconds after the pod gets created, and then period seconds is 5 seconds. Every 5 seconds is going to try out, and by the time 30 seconds reaches out, this is going to fail, and then we'll probably see this particular pod getting restarted. So let's create this pod quite easily. So kubectl uh, create hyphen have and then simple faulty. So this should create my pod. So let's see, get pod, and as you can see, the container is getting created here, and so it should get created in a while. It's still fetching, I believe, and yeah, it's now running, as you can see. So let's wait for a few seconds and see what happens. And yeah, okay. So let's try that again. Still running. And I can still see it's running, and there are no restarts yet. And we can also get, let's see what happens by, we can describe this particular pod as well. I can say this. Okay, so this says the liveness probe uh, is, it has failed, right? And but I don't see a restart happening here. But let's see why. And okay, so now it's showing as you can see the liveness probe. It shows as 2 restarts. So this is exactly what I wanted, and it took a while to do that. And yeah, so this is about the liveness probe, and it has restarted. And now you can make sure that Kubernetes listens for such kind of faulty errors and restart your pod as and when necessary. So this is a very good feature in Kubernetes. So let's see what are the best practices when implementing liveness probes. So in case if you are trying to use liveness probes with HTTP GET method, so it's always better to have a separate resource in your application, such as /health, that will respond back with what's usually expected. If in case something goes wrong, it's going to respond 500 error because there was a problem in that. So that's a good way of determining that the application is not working fine. And also when it comes to certain applications, you need to make sure that you are testing the application not on its dependent systems. For example, let's say you have a web application that depends on a database, and it fetches information from database. For whatever reason, if the connection fails, and if a connection fails, and you should not consider that as a faulty problem of the applications. Rather, you should focus on the database, not on the application, because application itself is not faulty. And also, when it comes to liveness probes, it's always best to keep the liveness probes very lightweight, just like what we just saw with reading a file, something like that, right? And so we can do some sort of a liveness probe tests of that sort. Okay, so that's all I would like to show today in terms of liveness probes, and we'll see you in another video very soon. Thank you very much.